Hi, this is Dr. Sweeney, and what we're going to do here is we are going to be looking at working with reading some algorithms. So we're going to look at a couple of different algorithms, two search algorithms, and then what we call a sort algorithm. And what we're going to do is we're going to go in and we're going to kind of like work through how do we read the algorithms, and then we're actually going to do the algorithms for some short lists, to do some short searches, and also to do some short sorting. Okay, because sometimes these things can take a very long time if you're doing by hand. But I think it matters a lot for you to actually go in and do the sorting, to actually go in and do the search, right? And to follow the algorithm, because it gives you a better sense of how to read the algorithm and how to run an algorithm. So let's take a look at this one. This one is going to be the linear search algorithm, okay? And if we look here, first our input is this x, and it's an integer. And so we'll have something that we're going to be searching for. And then we have A1 through AN, and that's our list of distinct integers that we're going to be searching through. All right, so we're going to go in, we're going to look through a list of integers for a particular integer. All right, and this is a very standard search. It's somewhat rote, right? Okay, but it should give us a very clear sense of how to read the algorithm. So we start out now, and we have we're going to set out with I equal to 1. So that's going to tell us where we're going to start. Right? Our starting point, all algorithms have to have a starting point as well as a set of inputs. And then we're going to start out with this while. And so while is going to indicate when we are going to be running this particular loop. Okay? So if I is less than or equal to n and x does not equal ai. All right? So we've got our starting point here that I equal to 1. Right? And it makes sense that that should be at the beginning because it's the starting point. Right? We also have our inputs. These are the things that we're going to be putting into the algorithm. And then now we've got our first command. So our while, we have here a while loop. And the while loop is going to say while we have these things, these conditions met, okay, then we are going to be continuing to run this loop. All right? So if I is less than or equal to n and x does not equal ai. So x is our integer. All right, and AI is wherever we are inside of that listing. All right, so this thing here says as long as we haven't found the value that we're looking for, right? So as long as we haven't found the value that we're looking for, and also what we have here is that says that the value that we're on is not the end of the list, and n is always the end of the list. Whatever listing that we have, the end of our data. And so that actually gives us a time to when we're going to end this particular loop, which is something that you also need. You need a time to like finish, okay? Now, what we get here is if I is less than or equal to n and x does not equal ai, then I is going to equal I plus 1. So essentially, if you think about this, what this statement is saying is this statement is actually saying, right, okay, it's saying if I am not at the end of the list, and I have not found what I'm looking for. So if that is the case, while that is the case, then what I'm going to do, this is the operation that I'm going to do, I'm going to let I equal I plus 1. That means that I will iterate again. I'll now go on to from 1 to 2 or from 2 to 3. Okay? And then finally, all right, I'm eventually going to hit either I is going to equal n or x is going to equal ai. Then once that happens, all right, I get if I is less than or equal to n, then the location is I. So I will return whatever I value that I get at that point. And we'll get an else here that says, else my location is 0. So what this is going to say over here, right, what that says here is, okay, now while loop has ended. While loop has ended, so there are two things that could have occurred. If we are not at the end of the list, then what we get is we get that x is equal to ai, right? Because we have to have these two conditions met. Remember from logic, if it's an and, they both have to be true. Okay? Well, if I is less than or equal to n, yes, then that means that this one, the x does not equal ai, is the false one. So that means that we found our value. X is going to equal ai. Else, right, that means that this is not the thing that happened. The else means that we've got the alternative, and the alternative is that I equals n. And if I equals n and we have not found our value, then we're going to return a location of 0. Because there is the possibility that the thing that I'm looking for is not actually in the list. And that's kind of like what this is saying. So we'll do one of the others, and then once we have that, we end, and then it's going to return location. And return location is either going to be the value where the input is located, or it'll be 0 because the value that we're looking for is not actually in the list. Okay? So let's try this out. All right, I'm going to erase my lines here. This is just for my emphasis. And I'm going to start out, and we're going to go, consider our input. Our input is we're going to look for 3 in the listing 793, -5. Now clearly 3 is in the location 3. That's where it is. It's the third value inside of the list. We already know that, okay? It's not a long list. We're fine. However, the thing is that you want to actually practice your algorithm, so let's do this, all right? So we start out with I. I is going to start at 1, okay? And so A1 equals 7, all right? And we look, I is less than n. So 1 is less than n. Well, what is n? Okay, n equals 4. That's the number of elements that I have in the list. 1, 2, 3, 4. That's how many I have in the list. And, okay, x does not equal ai. X does not equal ai, does not equal 7, right? That's basically 3 does not equal 7, because that's the thing we're looking for. And there we are. So consequently, we're now going to iterate. I is now going to become 1 plus 1, which equals 2. So now we're on to A2. A2 is going to be now 9. 1, we'll notice that I2 is less than or equal to 4, right? Because that's our n. And in addition to that, 3 does not equal 9. So we'll go on and we'll do our if statement again, right? If I less than or equal to n, then the location, we're going to go on and do my I, this thing right here, the iteration. So I is now going to be 2 plus 1, which equals 3. A3, my third term, is equal to 3. Now I'm going to notice that I, okay, which is 3 is less than or equal to 4, okay, but 3 does equal 3, so that ends my while loop. I now end my while loop, okay. Now I go on to this if else. I notice that if I is less than or equal to n, so I was 3, n was 4, that's true, then my location, so location, okay, is going to equal 3. And we're done. We don't need the else term because we actually have that. We have that. This condition is fulfilled. So we're going to return location 3. And there we've completed our search. And location 3 tells us that the third value in the listing is in fact the value that you're looking for. Okay? So that's how we actually run the algorithm. So let's try this out. Okay? You've gone in, you've seen the algorithm. Here's the algorithm right here. And let me give you another list. All right? So I'll give you a list down here so that you can do it on your own and just run through the list. So our input is going to be, we're going to have x is going to equal -6. Okay? And our listing is -1, 2, 0, 5, -3, 7, 8, and 9. Okay? So go ahead and run through that listing, right? Utilizing the algorithm. At the end, you should end up with location is 0. And that should be your answer there once you've actually run through the algorithm. So go ahead, use that input, okay, for the algorithm here, that linear search, and see if you can get to location 0. See if you can also work through the listing as I've worked through it, right? Just basically going through and making sure that you're like, okay, this is what the computer would do, right? And that'll help you to actually read the algorithm better. Now let's look at this binary search algorithm, and let's go through and let's read through it. So what we've got is we've got an input, x, it'll be an integer, and then we have a set of values, a1 through an. So your listing is n items long, okay? And those are increasing integers. So notice that the difference here that we have is that our integers have to be in order this time, okay? And that's what it means to be increasing integers. We have I is 1. And what you'll notice now too is we've got some notes here, and these notes are in these curly brackets. The curly brackets are not done by the computer. They're notes that are left oftentimes for, programmers or part of some information that's been given to you so that you know what it is exactly that the algorithm is doing, right? And so it kind of informs you a little bit better as to how to run the algorithm. All right, we'll have I equals 1, and j is then going to equal n, and that's where we're going to start. These are our starting points. I1, the very first value in the listing. J is now going to be the last value in the listing, a sub n, while I is less than j. So as long as I and j are, in fact, going to be different values, right? Because if I look here, I is going to be the left endpoint, j is the right endpoint. So the only time that this is not going to be true is when I ends up equaling j. They're not going to actually switch directions. J will never be, in fact, greater than I. All right? And then we'll get m is going to equal, and this is the floor function for I plus j divided by 2. So that's the value for I and the value for j. All right? So where we are in the sequence divided by 2. And then we'll take the floor. So that allows us to round it. So essentially, if you kind of think about what's happening here, is we've taken the values and we're going to say, okay, here's the midpoint. Here's the middle point right here. And we are then asked if x, now x is the integer that we're looking for, is greater than am, then we're going to move our I to m plus 1. So now our I has moved up to m plus 1. So we're now going to take the m plus 1th term, and that'll be the left endpoint of our search interval then. And then else j equals m, all right? And so if it's not true that x is greater than a sub m, then we're going to get that j will be will change to m. And so that will become our new right endpoint, okay? So like basically what's going to happen here, and what we'll do is I'll show it to you, is we're going to take, we'll have an interval, it's going to be a certain length, we're going to find its midpoint, okay? And we're going to determine whether or not, okay, is x in here or is x in here, right? And if x is in here, inside of that left side, then we're going to keep I the same, and we're going to change j. On the other hand, if x is over here on the right-hand side, then what we'll do is we'll change I, we'll make that I, or actually this next one, this one over here, we'll make that I. And then over here on this side, this will now still remain j. So j remains the same. Okay? So basically we're going to ask ourselves, well, where's x going to be located? And we can do that because x is in terms of a set of increasing integers. Right? So we have a set of increasing integers. Okay? So we do that, and if x equals ai, so at some point in time, what will happen is we'll actually get I equal to j. We're only going to have one value, right? And either x will equal ai, and then we're going to give the location as I, or the location will be 0, and if the location is 0, that means actually that we didn't find it. It wasn't actually in the list. Okay? Then we will return the location, and the location is going to be the subscript I of the term ai equal to x, or 0 if x is not found. Okay? So, let's take a look at this. Let's utilize an input. We're going to have our input, and our input here is going to actually be, we'll have x will equal 6, okay? And our set of integers is going to be -1, 0, 5, 6, 7, 9. 6, 7, 9, 10, and 11. Okay? So this is going to be our set of integers. So what we'll do now is we'll start with our inputs, right? We're going to be looking for 6. So that's going to be always our comparison. Our x is 6, and then we'll have a1 through an. So I want to think to myself, if I'm reading this, I want to say, okay, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8 in this case. Okay? So I equals 1, j equals 8. While I is less than j. So we're going to check that. I equals 1, j equals 8. So I is less than j. Right? 1 is less than 8. We're going to have m is going to equal the floor of 1 plus 8 divided by 2. Okay? So that is 9 divided by 2. That's 4.5. So that's equal to 4. Okay? 4. So now I'm going to look at my list. I got -1, 0, 5, 6, 7, 9, 10, 11. And I'm going to go to my fourth term. I got 1, 2, 3, 4. All right? So now what I see here is that A4, okay, is equal to 6. So A4 equals 6. All right? So 6, okay, in fact, equals 6. So if I look here, x is not greater than a sub m. Right? Our m here in this case was 4. And so 6 equals 6. So this is in fact not true. So we're going to make j equal to m. So j is now going to equal 4. So that's going to be the next step. Now, I is still less than j because I is equal to 1 still. I equals 1. J equals 4. So now I'm only going to consider this listing. I'm going to consider now -1, 0, 5, 6. Basically, I've cut off this piece right there. That piece is now gone away. It's not like it disappeared. It's just I'm no longer considering it inside of my algorithm. So now my new m is 4, or my new j is 4. So I'm going to take my floor, or m, is going to equal 4 plus 1 divided by 2. That's 5 divided by 2. That equals 2.5, and then its floor is going to end up being 2. Okay? And we're going to see that A2, right, is 0. A2 is 0. So 6, our x is greater than 0. So what that means is, okay, all right, we're still here. 6 is greater than 0. I will now become m plus 1. So I is now going to equal 2 plus 1, which equals 3. Okay? So we now have I equals 3, and j remains the same. J is going to be 4. So our new listing is just 5 and 6. Okay? Or those are just the ones that we're going to be considering. So now I'm going to iterate again. I'm going to take m. M is going to equal 3 plus 4 divided by 2. Okay? This is equal to 7 divided by 2. That's 3, so it's 3. All right? When we take the floor. So now I'm going to look. A3 is 5. A3 is 5. 5 is in fact not greater than 3, not greater than 6. So what happens? Right? J is then going to equal m. So j equals m. Excuse me. 6 is greater than 5. 6 is greater than 5. That's true. So I is now going to equal m plus 1. Or it equals 4. So now I is 4. J is 4. In this case, I is no longer bigger than j. I is no longer bigger than j. So I go in and I'm going to look and I'm going to say, okay, well, if I is no longer bigger than j, right, what happens? Right? The while loop ends and we get if x equals ai, then the location is I. So if we look here, ai equals 6. X is 6. So our location, or excuse me, A4 is 6. X is 6, so our location is 4. And that's what we get. We get that return. We get the return of the location, right? So we get this one, and so we return our location, and that will be 4. It is the 4th item inside of our increasing list. Okay? Now, what I'm going to do is I'm going to go back. I'm going to show the algorithm again, and I'll give you a list in which to search using the binary search. Now, this one took a little bit longer than the last one, but it was a much longer list. We had a list of 9 items here. Okay, so we had a list of 9 items, and in the linear search, we only had like a list of like 4 items, right? In this case, 6 was the 4th item, so maybe the linear search would have taken a little bit longer, a little bit shorter, hard to say. But if our list was much longer, right, and 6 was a later term, then that linear search would have taken a long time, right? Because we'd have to go through and search through every single term. This binary search actually cuts things quite significantly in terms of its time, right? Because we're just cutting our list in half over and over and over again. That's all we do, all right? Now, so what I want you to do is I want you to try this out on your own, okay? I want you to try this out on your own. And so we're going to have our input is we're going to have x is equal to 7. Okay, x will equal 7. And our listing here, all right, is going to be -3, -2, 0, 1, 5, 7, 8, 11, 23, and 27. Okay, and so there's our input. We're going to utilize the binary search, so you can use this searching. Okay, and I'll erase that for you. And go through and do the binary search. You know, kind of follow along with the algorithm, see if you can read the algorithm, or maybe you have to go back and kind of watch the video again, okay? So go ahead and do that, and then we'll take a look, one more look at a sort algorithm. So for our last algorithm to be read, we're going to be looking at this insertion sort. And the insertion sort is a very basic sort, not really incredibly efficient, but you know, what it'll do is it'll kind of illustrate for us a way of thinking about algorithms where we have, these aren't exactly nested. Well, we have some nested loops and then we have some sequential loops. Some while loops and for loops, right? And the whole idea here with an insertion sort is to get an increasing list of values, right? To sort a list of numbers into increasing order, okay? So we'll look here, and let's take, for example, we're going to take this one. We'll have 2, -3, 5, -1, and 7. All right? And so that'll be my list of numbers, and that'll be my input. All right? And notice that we need real numbers with n greater than or equal to 2. And we're going to start with j, right, equal to 2, and we're going to go from 2 to n. So in this case, it's going to go from 2 to 5, because we've got 5 values. N equals 5 in this case. So we're going to start out with j as 2. And then we'll go to I equals 1, and that's inside of our loop. I equals 1. All right? And then we're going to go to a while loop. So this is going to indicate for us, while this statement is true, we will do this thing. Okay? And if I look here, as I'm reading it, I'm just noticing that I'm just going to iterate I repeatedly. All right? In my while loop, all I'm doing is I'm increasing whatever I is going to end up being. So I may end up being a different number other than 1. So we'll start in, and we'll notice that A2 is equal to -3, and A1 is equal to 2. So in this case, -3 is not greater than 2. So we have this false statement. So what that means is that I is just going to stay exactly where it's at. We don't actually have to run the while loop at all. Okay? So I ends up just being 1. And we're going to make note of that for right now. Then my m, I'm going to assign m as aj. Notice that j is 2, so m is going to be -3. Okay? Next up, I've got this for loop, And what I want to do in the for loop is I got 4k assigned 0, 2, and we'll notice that this is going to be j is 2, minus I, which is 1, minus 1. So this is going to go from 0 to 0. Okay? So we're only going to do this once for k equals 0. And so I'm going to take a times 2 minus 0 is going to get assigned to a 2 minus 0 minus 1, which is a1. So I'm going to move a2 to a1. All right, that's what this is saying. Move a2 into a1. All right, and it's going to say a1. A1 then is gets me to, it makes me m. Okay, so a1 now. A2 gets assigned to A1, right? And we switch over A1 onto A2. So that means that my A1 now is equal to -3. And so now I get -3, 2, 5, -1, 7 is my new listing. And that's the first running of this loop because we went from k equals 0 to 0. So now we're going to notice, we're going to run this again. Now j gets increased, so j is now going to go to 3. Okay, and what we're going to see now is that while aj, right, we're going to set I equal to 1. And while aj is greater than ai, so aj, a3 is equal to 5, a1 is equal to -3, so 5 is greater than -3. So that tells me that I'm going to iterate. I'm going to take this now to I goes to 1 plus 1 is now going to equal 2. Okay? So now I'm going to compare A3 to A2. Right? And so 5 is greater than 2. So that's true. So I is now going to go to 2 plus 1, which equals 3. Okay? Now we compare A3 to A3. Well, 5, which is A3, is equal to 5. So now we hit our false. There's a false statement inside of the while loop. So we're going to assign m. So m now is going to equal 5. Okay? And we're going to notice that I is now equal to 3. So we're going to go from k equals 0 to 3 minus 1, which equals -1. And that's also false. Right? That's just false. So we don't actually have to run this at all, because that's going to go, you can't go from 0 to -1. It's in the wrong order. Okay? So now what we got here is, remember that I, at the end of our last run, was equal to 3. So what we're going to do is we're going to assign A3 will now equal 5. Right? Because that's our m. M is 5. So now we're going to assign A3 to be 5. So A3 is now 5. And that gives me my list, -3, 2, 5. -1, and 7. So let's do this one more time. So now I have a listing now of -3, 2, 5, -1, 7. Okay? So j has now iterated again, and j's gone on to 4. And we're going to set I to 1 again. Okay? So we're going to set I to 1 again. And so now we're going to check AJ against AI. So A4, okay, equals, in this case, -1. A1 equals -3. So what that means is that, right, -1 is in fact greater than -3. So I is now going to iterate. It's going to go 1 plus 1, which equals 2. Okay? Then I'm going to have, all right, well, if that's the case, now I've got to try it again. I'm going to take A4, right? And I'm going to see, is that bigger than 2? Well, A4 is actually not greater than A2. So we get a false there. All right? And so consequently, what we'll do is we're going to stop. We're going to note that I equals 2 in this case. And we're going to let m be the value for AJ. So m is going to be -1. Next up, I'm going to look and I'm going to go from k equals 0 to 4 minus 2 minus 1, which equals 1. So we're going to go from k equals 0 to 1. And what we're going to do is we're going to start out with a4 minus 0, okay, is now going to equal a4 minus 0 minus 1, which is a3. So we just pushed a4 down to a3, okay, and moved a4 up. Then we're going to see, okay, well, I've got to do it for 1 as well. So a4 minus 1, right, that's now our a3, okay, is going to end up equaling a 4 minus 1, which is a2. And we'll notice that I equals 2. So now a2, which is where we had, a2 is now going to equal negative 1. So what we've essentially done here, what's occurred, is we started at negative 1, right? Okay. Or we had we had negative 3, we had 2, 5, negative 1, and then 7. Okay. And so what we did essentially here was we said, okay, so I'm going to take this a4 term, I'm going to bump it down 1, and then I'm going to bump it down again, another one, right? So basically what I'm going to do is I'm going to end up inserting negative 1 in. So this ends up being now negative 1, 3, negative 1, 2, 5, and then 7. And that's our fourth term. That actually is our fourth insertion. Now let's look at this last one, and this is where j equals 5. Okay? And so we're going to start at I as 2. And we're going to compare, and we're going to start out with a5, or I as 1, excuse me, a5 against negative 3. So what we notice there is that, in fact, that a5 is greater than negative 3, so I is now going to iterate to 1 plus 1 is going to equal to 2. Okay? Now we'll compare a5 against negative 1. 7 is greater than negative 1, so I is going to go up again. It's going to now go up to 3. Then we're going to get 7 is greater than 2, so I is now going to go up again. 3 plus 1, it's going to equal 4. Then we're going to go up again, so we're going to compare 7 against 5. So 7 is greater than 5. So I is now going to say, okay, it's going to be 4 plus 1, which equals 5. All right, so I is now 5. So 5, or 7, equals 7, so we can end the while loop. All right, this ends up giving us false. And so we're done. Now I'm going to take a look. I'm going to assign M is now going to be AJ. AJ is 7, so M will be 7. And then we're going to have K is going to go from 0 to 5 minus 1, which equals negative 1, right? So this is also false. And so we're done with the for loop. So what that means now is that A5, because I is 5, is just going to equal 7. So we actually haven't inserted it anywhere, or we actually inserted it at the end. That's actually where we did our insert. So consequently, what I get now is I get my list of numbers, negative 3, negative 1, 2, 5, and 7. And that's my output. Negative 3, negative 1, 2, 5, and 7. And there's your output. Now it's your turn. What you want to do now is follow through the algorithm, similar to the way that I did, just to get yourself more acquainted with how it is that we read algorithms, how we run while loops and for loops. Okay, I know you can sort a list of numbers and put them in order. That's no problem. What you want to do is you want to get used to how it is that we read the algorithms. Okay? Remember, at each step, you're going to have to iterate. This one was kind of tricky, like when I was first reading it, and so it might take you a little bit of time. All right, so this ends the video. And our work with reading. We're going to get a lot more practice with reading algorithms, so I hope this gives you a good introduction.